The concept of an artificial river cutting through a nation's heartland is nothing new. But what if we told you that Thailand is on the verge of creating a $28 billion engineering marvel that could rival the Panama Canal? In a daring move that could reshape global shipping routes, Thailand plans to construct an enormous artificial canal spanning nearly 120 kilometers to connect the Gulf of Thailand with the Andaman Sea. This ambitious project aims to streamline maritime traffic by offering a shortcut that could save shipping companies up to 3 days of sailing and reduce distances by over 1,200 kilometers. As oil tankers and cargo ships seek more efficient routes, this canal promises to become a game changer in global logistics. However, with such monumental plans come significant challenges and potential consequences. Will this colossal infrastructure project revolutionize shipping or face hurdles that could threaten its success? This is the Strait of Malacca, a tiny sliver of water separating the Malay Peninsula from Sumatra. This is one of the busiest shipping lanes in the world, with nearly 100,000 vessels passing through each year, carrying goods worth trillions of dollars. Now, imagine all these ships trying to squeeze through a narrow, crowded corridor. It's like trying to funnel a bustling city's traffic through a single-lane road. The risks are high. Congestion, collisions, in a single accident could disrupt global trade, as vividly demonstrated by the Suez Canal blockage in 2021. Now, move to the northeast on the map to the Isthmus of Kra in Thailand. This narrow strip of land, just 40 kilometers wide at its thinnest point, connects the Gulf of Thailand to the Andaman Sea. Here, Thailand envisions an alternative, a canal cutting straight across the isthmus, bypassing the Strait of Malacca entirely. This proposed Thai canal isn't a new idea. Kings and engineers have dreamt about it since the 17th century. Back then, Thailand lacked the technology to bring this vision to life, and colonial powers like Britain had their own reasons for keeping the project in limbo, preferring to route trade through their controlled hubs like Singapore. Fast forward to today, and the stakes have never been higher. Unlike the Panama Canal, it wouldn't need an elaborate system of locks, allowing for a more straightforward transit. This canal could save ships up to 3 days of travel and 1,200 kilometers of distance, translating to significant cost savings. Beyond just a shortcut, this canal could transform Thailand into a major global logistics hub, a Southeast Asian answer to Singapore. But such a massive endeavor brings monumental challenges: displacement of communities, environmental impact, and geopolitical ripples in an already tense region. What kind of technology and innovation will be employed to carve out this new maritime marvel? First, consider the sheer scale of this project. The canal will be 128 kilometers long, 400 meters wide, and 25 meters deep. This means that massive amounts of earth and rock must be moved to create a pathway wide and deep enough for large ships. The first step involves extensive geological surveys. Engineers need to understand the type of soil and rock they will be digging through. This helps them plan the most efficient way to excavate the material. Once the surveys are complete, construction can begin. Large-scale earth-moving equipment like excavators and bulldozers will start the massive task of digging out the canal. This isn't just a simple ditch we're talking about. The canal must be deep enough to allow the largest ships to pass through without hitting the bottom. To achieve this, the engineers will need to remove millions of cubic meters of earth. But where does all this earth go? Some of it will be used to build up the banks of the canal, ensuring they're strong and stable. The rest will be transported to designated disposal sites. In some cases, the material might even be used to create artificial islands or reinforce coastal areas. Now, let's talk about the water. The canal will connect two significant bodies of water, the Gulf of Thailand and the Andaman Sea. These two seas are at different levels, so managing water flow is a crucial aspect of the project. Unlike the Panama Canal, which uses locks to raise and lower ships to different water levels, the Thai Canal will be built entirely at sea level. This design choice eliminates the need for a complex system of locks, which simplifies the construction process but introduces other challenges. One major challenge is ensuring that water flows smoothly between the Gulf of Thailand and the Andaman Sea without causing flooding or erosion. To achieve this, engineers will construct a series of barriers and channels along the canal. These structures are essential for controlling the speed and direction of water flow. For example, barriers will be placed at strategic points to slow down the water and prevent it from rushing through the canal too quickly. This helps to maintain the stability of the canal banks and prevent erosion, which could damage the canal over time. Channels, on the other hand, will be designed to guide the water flow in a controlled manner. By directing the water through these channels, engineers can ensure that it moves at a steady pace, reducing the risk of sudden surges that could endanger ships and the canal structure. These measures are crucial for maintaining a safe and navigable waterway for the vessels that will pass through. Additionally, sensors and monitoring systems will be installed along the canal to track water levels and flow rates in real time. This technology will allow engineers to make adjustments as needed to manage any changes in water conditions, such as those caused by seasonal variations or extreme weather events. By continuously monitoring and managing the water flow, the canal can remain a safe and efficient route for maritime traffic. Speaking of ships, the canal needs to be wide enough for two-way traffic. This means constructing a canal that is at least 400 meters wide. To put that into perspective, that's wide enough for two large container ships to pass each other with plenty of room to spare. This width also allows for future expansion if larger ships are built in the coming decades. Once completed, it will provide a direct route for ships traveling between the Indian and Pacific Oceans. For example, a decently sized oil tanker could save as much as $350,000 per trip by taking the shorter route. One of the key benefits of this canal is the potential to transform Thailand into a global shipping and logistics hub, similar to Singapore. China, which has shown interest in helping build the canal, stands to benefit significantly as well. By supporting the construction of the Thai Canal, China secures an alternate route for its imports and exports, bypassing the heavily monitored Strait of Malacca. This strategic move enhances China's maritime security and trade efficiency, reducing its dependence on routes controlled by the United States and its Southeast Asian allies. However, the construction of the Thai Canal is not without its challenges and criticisms. The social and environmental costs are significant. An estimated 60,000 people will be directly displaced by the canal's construction, not to mention the tens of thousands of more, such as local fishermen and farmers, whose livelihoods might be affected. The project will also disrupt local ecosystems, destroying vegetation and marine life along the coasts. Another major criticism is that the canal will physically divide Thailand in two, potentially exacerbating regional tensions. The southern provinces, which are ethnically distinct and have long-standing separatist movements, might feel further isolated from the rest of the country. This division could fuel secessionist sentiments and complicate national unity. If you enjoyed this video and want to stay updated on similar initiatives, please like, subscribe, and leave a comment below. Don't forget to turn on notifications so you never miss an update.